In this track, we're going to cover some basic reading input and writing simple output used in Python, along with a little bit on error control. So two really important functions that you'll want to get familiar with for extracting data from users and converting that user's input into its appropriate numerical value or type, or input and eval. And so we'll start off with input is accepts a string which is used as a command prompt, sort of indicate what the user should do. The simple example here is saying asking for the user to input A. So it's the string capital I input and space A colon space, and the user is expected to respond with a value, and that would be stored in variable A. And then we would ask the interpreter to print it. Print was stored in A along with what the type of the data it is. And then subsequently we would call eval to evaluate that data, which will really be a string, and convert it to the appropriate type. And so here's an example where we've asked the user for the input, and again, input and space A colon space would be at the command prompt. Let's suppose the user typed 5.0. Well, then the first print would basically print what it is that the user provided, but as indicated next to it, the type of that data would be a string. In other words, that everything the user types is going to be considered a string. So when you store that in a variable, that's going to be considered a string regardless. So now if you called eval on that string, which is stored in A, which is indicated here, stored into B, print B, and then its type, well, it's still 5.0, but now it's a float, which is indicated by this type here. So it's very important to remember to call the eval function if you're going to actually work with 5.0 in this case, which the user clearly intends you to use that as a numerical value. But like many languages, user input is always going to be considered a string because it's the most general format that it can accept the data. Now let's do another example. Let's suppose that the user had typed an expression as indicated here. Suppose the user had typed 2 star star 3. Keep in mind that star star normally would be interpreted as exponentiation. 2 is an integer, 3 is an integer, and so what we're looking at is 2 to the 3rd power, which is 8. But again, if we ask the interpreter to print what is stored in A, it will return exactly what the user provided, which was 2 followed by 2 asterisks and the number 3, and it's stored as a string. But once you call eval, it's almost like thinking I'm going to execute this expression, which would be the exponential operator in play. And so that in this case, B, which gets the evaluation of the string 2 star star 3, is 8, as we would expect. But the type now is an integer. If the 3 or the 2 had been 2.0 or 3.0, then it would have been a float. But in this case, both of those operands on both sides of the star star are integers, so the resulting exponential result would be an integer. Now, as the input function, as we just learned, we'll take all the user's input and convert it to a string. The print function will convert all the inputs to strings for output. So let's suppose, for example, that A was a floating, stored this floating point value, 123.456, and then we had a simple list of integers stored in B, 1, 2, 3, and 4. So then upon calling print A, comma B, like this, then you would get, that's a little bit of an erroneous value there, let's take that out, you would get A being 123.456 as we'd expect, followed by the list, and there would be a default space in between those two that the interpreter would provide. They would not be rammed together, so there would be a space between them. If you needed to jump to the next line, very similar like you would in formats of in C and C++, you can always insert a new line illustrated here. If you would just you would do the \n for a new line, then you would get the outputs indicated here, where A would be printed, A equals followed by its value, B equals would follow on the next line with the list there. You can format output in Python in somewhat similar ways that you would do it in languages that you've already seen, but the syntax is a little different. Formats depend on the data type, and of course common formats are the form, say WD or W.df or W.de. W is the width, how many spaces that you want to use. D is the number of digits, and F or E would indicate that you're doing floating point or exponential notation. So I've got two examples here. Suppose you again have this float stored in A, say it's 123.456, and N is a large integer like 5,789. So the first print is an illustration of providing a format. The syntax of a format has to be, and you have to first of all provide a string that contains the format. So every format is in the string provided to the print, and you use curly braces and then have a leading colon. All right, that's just the syntax that you need to use before the format is actually read. So again, it looks like this. You have the curly brackets and then a leading colon and then now a format, in this case 6.2f, which means I'm going to have 6 spaces allocated for this data value, which is going to come from A, 2 of which will be the number of decimal digits that we'll use. And it's going to be a floating point representation. Then you follow the string for the format with this function call, just to format A based on that string. And you can have several formats and several variables inside the format function here. So there's only one here because I've only got one format, but you could have several formats and several values to be formatted, parameters passed to format. In this particular example, if you only have 6 spaces and 2 are reserved for the decimal, then it's going to basically chop this 6 off because it can't get the 6th. It can't get that last decimal place in. You only asked for 2. So if you only ask for 2, it'll allocate 6 spaces and make sure it's preserved the non-fraction part. So it's got 123 for sure, .45, and stops. So it is possible to accidentally truncate on the outputs just because you didn't provide enough decimal spaces to see all the accuracy perhaps you wanted. But this shows you how the format works. Second case is just going back to the fact that we have an integer, so there's no F there. You would just use a D format. How many digits, integer digits do you want to see? In this case, we want to see 7. So again, the format is curly brackets with a leading colon and then the actual format. And then that string dotted with a call to the format function for that variable will get this particular format applied to that variable. So in this case, we're going to print N equals and then that format. And if you allocate 7 spaces, it will by default right justify. So the 4 digits that are actually in N will be right justified, and you would have 3 blanks right here leading to it. Why 3? Because you allocated 7. Okay. So the default is to right justify. This next example illustrates some additional features. First of all, if we go back to our example of the floating point value in A and the integer stored in N, you can always have some other character padding on the left as you right justify. So remember earlier we just had a :7 and it padded blanks on the left of 5,789 because it would right justify it. But if you wanted to pad it with a 0, you can put that 0 character right before the 7, and that might be useful sometimes. in terms of making data line up in certain ways. So you can pad with other things than spaces, which is kind of nice. And then here again is an example of how to format two items with one print. So you actually have in order, you have an exponential format for A and you have an integer format for N. And basically you just use curly braces to separate each of the formats, and the interpreter will use the formats in their appropriate order as it reads through these parameters, A and N. So in this example, you're using exponential format for A, so that's why it's in scientific notation, it would be 1.2345 E plus 002. That's 11 spaces to fit the exponent, what would fit in the exponential notation, and would use 3 particular digits for the exponent there, 002. Okay, it can't fit the digit 6 in again because it would need you need 12.3e format to get that in there. Again, the 7 spaces allocated for n, you would write justify and therefore leave 3 blanks, leading the 5789 on the print. Now, I just changed the screen because I went to verify with the interpreter on the 11.3e formatting, because in the previous example I allocated 3 spaces for the exponents. Now the 3 spaces are clearly for the width field, which of the fraction. So what comes after the dot on the format, in this case the 3, should be for the fraction part of the exponential notation. It's not what I had previously. And I needed to double check this because when it does this exponential format, and it goes from 2, 3, 4, and noticing there's more digits, it has to only format 3. So it actually will, in this case, round the 4 to a 5. So this is actually the correct way for printing this that particular value in scientific notation with that format in Python. So it does use the 11 spaces, write justified. Only 2 though is necessary for for most of the exponential formats here. And but what's important here, and this is why I had to rerun it to clarify it, is that it does exactly what you want it to do, but if it needs to round on that last digit in the fraction, it's going to do that. So it actually rounded. You don't see 1.234. You see 1.235 because it's rounded. That right justifies, so there's going to be 2 leading blanks of this 11 spaces that was allocated for the format. Not going to get into too many details now about the specifics of how things would look, but if you're trying to get things to look a certain way and you notice that some of the digits aren't there anymore, it's because it's had to fit it, but it will actually round is the important point. It's actually going to round to try to fit it in that format that you want. So I wanted to clarify that. With regard to error control, some of you may be familiar with languages like Java that have try and except blocks, and so Python is taken that on a little bit to help with managing errors and warnings. It's important to see the basic syntax here is just to have a try block, and that's indicated with the keyword try followed by a colon, and then the code that you're testing to make sure it works appropriately. But if you're going to capture any exceptions, this is the block that you're going to capture them. And then you provide an except keyword and put an exception on the error that you're trying to capture. And you would look up in the Python reference online manuals, so forth, to figure out the name, the actual specific name. Here's an example where clearly you're in danger of dividing by 0, so there is a particular exception called 0 division error that would be captured out of this code block. And by specifying it here on this except block of the try, then you could execute code here or tell the user, for example, the exception's been captured and we're going to print divide by 0. But as indicated here below as well as on the top, if you drop this error, particular syntax here, and you just say try code except, then every possible exception that could be caught would. So for this particular example, it's only going to catch the 0 division error because that's what you specified. If you don't put this 0 division error here, if you totally just left this particular keyword out and just had except, colon, and then some code, every possible exception that could be found in your try block would actually be printed to would be captured, and you could do different things with them. Most of the time, however, you're going to do something like this: 0 divides, or square roots of negative numbers. Very simple types of things that you might want to catch in your code.